Okay, if you haven't yet tried this one on your own, here's what you need to do. Listen to what I'm going to say, but then go back to the slide and try this on your own. Find all integers that are solutions of both inequalities. So all of the values of x that are less than -4 and greater than -8. And you could plot them on the number line, trying to find that set of numbers that satisfies both of those inequalities. Go back, do that on your own, and then come back and watch this explanation. Okay, the numbers that are less than -4 would be numbers like -5, -6, -7. I should say the integers. -8, -9, all the way to -infinity. The numbers that are greater than -8 would be numbers like -7, -6, -5, -4, -3, all the way to positive infinity. The ones that are solutions to both would be just these. -5. I'm going to show you set notation. -5, -6, -7. That's an unfortunate glitch. That's set notation. Yeah, that is what I should do because we specified integers. Now let me clean this up a little bit. If I did not specify integers, if I just said find all numbers, then it would start at -4, but not include -4. And it would start on the other end at -8, but not include -8, but it would be all values in between. What we had been doing before was an arrow going this way, an arrow going this way, and the overlap is called the intersection. The intersection would be the numbers that are in both sets, both solution sets. Like x is less than 4 would be from -infinity to -4, non-inclusive because it doesn't equal -4. And for x is greater than -8, it would start at -8, go all the way up to infinity. But the numbers that are in both sets are all of the numbers in between -4 and -8. If I went back to integers only, and there's this glitch that I know about, but I can't really fix it. It's actually a Microsoft issue, and on the forums for years, teachers have been asking for help with this, to no avail. If I make this circle all the integers that are less than -4, and I make this circle all of the integers that are greater than -8, well, some of the numbers that would be in this circle would be like +10, 0, -7, and some of the very small numbers that would be in this would be like -15, -83. But the ones that would be in the intersection would be the -5, the -6, and the -7 that we identified initially, which is why this shouldn't be here. But I could have a number like -2 here, because that would be greater than -8, but not less than -4. So, this intersection is the overlap of these two sets. Well, so is this. If I had an arrow going to the left and an arrow going to the right, the numbers that are in the overlap of those two arrows represent the solution. So this is called a compound inequality, and there's a shorter way to write it. If I say x is less than -4 and greater than -8, that's a compound inequality. Because in much the same way on last night's assignment where you read from the x, if you read from left to right, this says x is less than -4. If you start at the x and read right to left, it says x is greater than -8. So this is the correct way to write this situation, where it's this and this. It's called a compound inequality. Forgot I had that. If you're watching this video and you haven't tried this on your own yet, please go back to the last slide and try it on your own.